paper 6. Question number 46 is an alkaloid contains 17.28 percentage of nitrogen and its molecular weight is 162. We need to calculate the number of nitrogen atoms. Over here it contains 17.28% of the nitrogen. That indicates the 100 grams of this particular alkaloid will be containing around 17.28 grams of nitrogen. Therefore, the 162 grams of the alkaloid will be containing 162 into 17.28 divided by 100. That's equals to, it comes around 27.9, almost equals to 28. Atomic weight of nitrogen is 14. So this is divided by 14, that comes 2. So answer is option D. Question number 47. The hemoglobin contains 0.33 percentage of iron by weight. Molecular weight of hemoglobin is given. We need to calculate the number of atoms of the nitrogen. The similar type of question is there. So 100 grams of the hemoglobin, that is containing 0.33% of iron, that is 0.33 grams of iron. Therefore 67,200 grams of hemoglobin will contain 67,200 multiplied by 0.33 upon 100. So I am keeping this as it is. This are the that is mass of the iron we'll get. This is divided by its atomic mass. Atomic mass of iron is 56. So if we'll divide it, we'll get the number of atoms of the iron. So this answer comes out to be 4. Therefore answer is option C. Question number 48 is the graph representing the node. The node is generally represented by the decrease in the value of the psi and then sudden increase as the distance changes. Therefore option C. The maximum energy which is possessed by electron when it is present, generally we have an equation E is inversely proportional to 1 minus of 1 upon n square. Now as the n increases, the E also increases. Therefore as at the infinite distance, the electron will be definitely having the more energy. Therefore option D. Question number 50. Which of the following element is the most electropositive? Amongst them, the most electropositive metal is the magnesium, belongs to group 2. Left to right, electropositivity goes on decreasing. Therefore option B. Which type of bond is formed between H2S? H2S is having the covalent bond between the sharing of electron between the hydrogen and sulfur. Therefore option B. Question number 52. Which of the following is non-linear molecule? In the case of non-linear, when I am talking about the hybridization of this, we have a formula: number of hybrid orbitals is equals to half into number of valence electrons plus number of monovalent atoms plus the charge on anion minus the charge on the cation. So if we'll talk about the first case, that is SO3. SO3 has number of hybrid orbital calculation. So hybrid orbitals for SO3, that is half outermost shell electrons which is present in the case of the sulfur are 6 plus there is no monovalent atom, there is no charge on the cation or anion. So this is all values are 0. So 6 into half, that is equals to 3. Then in case of carbon dioxide, this is half into 4, that is equals to 2. Again the similar case over here, this answer will also comes 2. Then the last case, beryllium, this is half into beryllium outermost shell electrons are 2 plus monovalent atoms are 2, so that is equals to 2. They all are sp hybridized, therefore these are all linear, while this is sp2 hybridized, definitely that is non-linear. Hence our option is option A. Question number 53 is the RMS velocity of the molecule having density 4 kilogram per meter cube and pressure 1.2 into 10⁵ Newton per meter square The formula of the RMS velocity is equal to square root of 3p into d, pressure upon density. That's equals to 3. Pressure is given 1.2 into 10 raised to 5, while density is given, that is 4. If we'll calculate this will come around 300 meter per second. Hence option A. Question number 54. The Cp value for the nitrogen gas is given. So Cp given is 7 joule per Kelvin per mole. Then value of delta H we need to calculate. The weight of nitrogen is given 28. So number of moles can be calculated 28 upon 14. That's equals to 2. The temperatures are given. T1 converted into Kelvin, it's 273 Kelvin, and T2 is 373 Kelvin. We have a formula delta H is equals to Cp T2 minus T1. Cp is given n into Cp. N is 2, Cp is 7 into 373 minus 273. So this is 14 into 100. So 1400 joule. Hence option C. Question number 55. In this case, three equations are given. Carbon converted into carbon dioxide, carbon converted into carbon monoxide, and carbon monoxide into carbon dioxide. The heat of reaction for first is Q, next is minus 12, and next is minus 10 respectively given. We need to find out the value of Q. If I have to get the equation number 1, that can be obtained by addition of equation 2 and 3. So therefore, we can add the enthalpies of 2. So minus 12 minus 10, that's equals to minus 22. Hence option is C. Question number 56. The solubility of AgI in NaI solution is less than that in pure water because the AgI will be less soluble in NaI. That is because of the common ion effect, because iodine will be already present in excess, that is common ion effect will decrease the solubility of AgI. So temperature of the solution decreases? No. Solubility product of AgI is less than NaI, it is more, and because of the common ion effect. So option C. In which of the following reaction the hydrogen acting as oxidizing agent? So if the hydrogen acts as oxidizing agent, itself undergoes the reduction. And in reduction, the oxidation state of hydrogen should decrease. So in the case of hydrogen, when I'm talking about H2, the oxidation state is 0, which should change to the negative. It should come to the minus 1. So option A, where LiH is present, Li is plus 1, the hydrogen is minus 1. Definitely here it is decreasing, hence option is A. Question number 58, the conversion is which of the following is the oxidation reaction? In oxidation, the oxidation state should increase. So this is becoming minus 2, it remains same. Plus 2 is becoming 0, so it is again decreasing. Plus 1 is becoming 0, so decreasing. Minus 1 is becoming 0. So this is increasing, hence option D. Question number 59 is the pH of the solution of H2O2 is 6. Some chlorine gas is bubbled through this solution. So if we allow H2O2 to react with chlorine, it will give us formation of HCl plus O2. So what will happen? The pH of resultant solution becomes 8. If HCl is formed, the solution should have pH less than 6. Hydrogen gas is liberated from the resultant solution. We get the liberation of oxygen gas. pH of the resultant solution becomes less than 6 and oxygen is liberated. Definitely the option C is the correct statement. The ionic compound BaSO4 is insoluble in water. The reason behind it's definitely having the high lattice energy. So option A is right. Low lattice energy? No. Low hydration energy? Yes, definitely this is also the correct statement. Therefore option D. The carborundum is nothing but silicon carbide. Hence option A. Moissan boron is nothing but the amorphous boron, which is black in color, and it is around 95.98% of boron is present. So definitely it's having the low purity. So it is an amorphous boron of low purity. Hence option A. Which of the following order is correct related to the minus I effect? So if I talk about the electron withdrawing effect, it's highest in case of fluorine, highly electronegative, then alkoxide, and then in case of the amine, because amine have the lone pair of electron, they show the electron donating tendency rather. Therefore, option B over here is the correct order for this substituents. In the series, we have C2H2. C2H2 is nothing but CH triple bond CH. This is on treatment with NaNH2. This is having the acidic proton, so this can form a salt, CH triple bond C, Na plus C minus. This is on further treatment with CH3I. This will replace the sodium and alkylation will take place, CH3, followed by the hydrolysis. When hydrolysis will take place, it will give us formation of CH2 double bond. This will become COH, CH3. The tautomerism will take place, proton will be transferred here, double bond will be shifted here. So I'll get CH3, C double bond O, CH3. So we'll get formation of acetone, hence option B. Question number 65 is the most stable alkene is. The most stable alkene is the one which is having more substitution. Hence option A is the most substituted alkene, is the most stable alkene. Which of the following is the sink for carbon monoxide, hemoglobin, microorganism present in soil, ocean and the plants? The sink for the carbon monoxide, the best one is the microorganisms which can decompose the carbon monoxide. Question number 67 is which is not correct statement for the ionic solids in which positive and negative ions are held by the strong electrostatic force of attraction. This is related to the radius ratio rule from the solid state. The radius of R plus upon R minus increases as the coordination number increases. Yes, this is a correct statement. As the difference in the size of the ion increases, coordination number is expected to increase. The coordination number is 8 when the ratio is between 0.225 to 0.414. It has to be 6 when this ratio is found. When it is 8, it is found to be more than 0.75. So definitely answer is C, which is incorrect statement. Question number 68. Which of the following crystal alternates the tetrahedral voids are occupied? Alternate tetrahedral voids are occupied in ZnS where the coordination number is 4. Which of the following is incorrect? Relative lowering of vapor pressure is independent. Definitely it is independent of the nature of the solute. Then vapor pressure of the solution is lower than the vapor pressure of solvent. Yes, always it causes the lowering of vapor pressure. Vapor pressure is colligative property. Definitely it's a colligative property. Relative lowering pressure is directly proportional to the mole fraction. This is incorrect. It is not directly proportional. It is equals to the mole fraction. Therefore option D. Question number 70. In humid day in a summer, mole fraction of a gaseous water in air is at 25 degrees Celsius can be high as 0.07287. Assuming the total pressure is 0.977 atmosphere, what is the partial pressure of the dry air? First of all, we'll calculate the partial pressure of the water. So pressure of the water is nothing but the mole fraction of the water into the total pressure. Mole fraction of the water is given, that is 0.0287, and the total pressure is given 0.977. So this comes out to be 0.028 atmosphere. Now the total pressure is nothing but the pressure of the dry air plus the pressure of the water. So to calculate pressure of the dry air, we can subtract the pressure of the water from the total pressure. Total pressure is 0.977 minus 0.028. This comes out to be 0.949 atmosphere. Hence option B. Question number 71. The corrosion of the iron is essentially in an electrochemical phenomenon where the cell reactions are. When we talk about the corrosion of iron, Fe is oxidized to Fe2 plus by loss of 2 electrons. This is nothing but the anode reaction. Whereas the oxygen is dissolved in the water so as to form the hydroxide ion. Therefore, this is the cathodic reaction. Hence, our option is option A, where the Fe is oxidized to Fe2 plus and dissolved oxygen in water is reduced to OH minus ion. Question number 72 is, the first order reaction is 20% complete in 10 minutes. What is the rate constant? We have an equation K is equals to 2.303 upon T log to the base 10 A upon A minus X. So this is 2.303, time is given is 10, log of initial is 100% divided by 20% completed. So 100 minus 20, that is 80. So this is 2.303 upon 10 log of, this is log 10 minus 8. So this is log 10 minus log of 8. I am writing it as 2 raised to 3. So 3 log 2. So when you calculate this, this comes out to be 0.0223. Therefore, our option is option B. Question number 73. The following mechanism has been proposed for the reaction of NO with Br2, giving the NOBr formation. There are two-step reaction. The second step is a rate determining step. What is the order of reaction with respect to NO? So if I'll talk about the second step is a rate determining step. So the rate of reaction is equals to K into concentration of NOBr2 into concentration of NO. But NOBr2, if you'll find, this is kind of like an intermediate form in the reaction. So it is in equilibrium. So for the first equation, if I apply the equilibrium constant, so the K equilibrium will be concentration of NOBr2 divided by concentration of NO into concentration of Br2. So therefore, we can say concentration of NOBr2 is equals to K equilibrium into concentration of NO into Br2. If we substitute the value of NOBr2 in this equation, we'll get rate of equation is equals to K into K equilibrium NO square into Br2. Therefore, this reaction is second order with respect to NO. Hence, our option is D. Question number 74. The fresh precipitate can be transformed into colloidal state. The process of fresh precipitate conversion to the colloidal state is called as a peptidization. So, it is peptidization. The next, which one of the ore is of sodium? Sylvine, siderite, spodumene and soda ash. Soda ash is Na2CO3. So, definitely it is the ore of sodium. Titanium contains the mineral found in our country. Bauxite is the aluminium. Chalcopyrite is the copper pyrite type. Then ilmenite is that is of the titanium, which is FeOTiO2. Therefore, option C. Question number 77. Which of the following is a configuration of the noble gas? For this, the configuration has to be completely filled. This is incomplete third shell. Over here, it's a complete shell. Therefore, option C. This is the configuration of the neon gas. 78. K2Cr2O7, when it is heated, it gives the K2Cr O4. With the liberation of oxygen gas, this compound is Cr2O3. Therefore, option is C. Question number 79. Which of the following is correct? Duralumin, this is aluminium, copper, magnesium, and the last is given silver, which is incorrect. It has to be Mn. German silver is a copper, zinc, and it is generally nickel. So this is also incorrect. Gunmetal is copper, zinc, and tin. This is correct option. And the solder is generally the copper with the zinc or copper with the silver. So this is incorrect again. Therefore, option C is the correct option for this. Question number 80. X is containing 0.02 mole of the first complex and 0.02 mole of the second complex was prepared in 2 liter. So if we take 1 liter of the X and it is allowed to react with AgNO3. So if we allow it to react with the AgNO3, we'll get formation of the AgBr complex. So if we start with 0.02 mole, I'll get 0.02 mole over here. If we start with 1 liter of X and treat with the beryllium chloride, the second complex will precipitate to barium sulfate. Same, if we start with 0.02 mole, we'll get the 0.02 mole of the barium sulfate. But rather than taking 2 liters, which was the original solution, they have taken 1 liter. So half of the concentration you will get it. So we'll get 0.01 of the first complex and 0.01 of the second complex. Hence, option is A. Identify A and B in the following reaction. The alcohol is obtained by the reaction of A and B with the NaOH and HgOH. This is generally the reaction of alkyl halide on treatment with the NaOH or HgOH that gives corresponding alcohol. So if we are getting the formation of ethyl alcohol, the starting material, both of them should be ethyl chloride. Hence option D. The etherates. Etherates are generally, for example, if we have ether molecule and if we allow it to react with the Lewis acid, for example, like BF3, since boron is electron deficient and oxygen has the lone pair, it can form a complex with the ether. Therefore, this kind of complex with the Lewis acids is called as the etherates. Hence option C. Question number 83. Which of the following will not react with NaOH? NaOH is a base in nature, so the acidic compound will react with it. Out of all, this is the compound which is acidic because of presence of the nitro group, electron withdrawing groups over here. Option B will not react because alcohols are neutral in nature, not the acidic, so they will not react with NaOH. Urea on slow heating. If I'll talk about urea, it's NH2, C double bond O, NH2. 2 molecules of which, if we'll take, which is on slow heating, we'll lose ammonia. So NH2 is lost from here and H is lost from here. So I'll get NH2, C double bond O. Over here, only this N is left, NH is left. So NH, C double bond O, NH2. This is kind of biureate is formed in the reaction. Hence option B. We have question number 85, N-butylamine. N-butylamine is like CH3, CH2, CH2, 4 carbon with NH2. So this is primary amine. Then diethylamine. So this is C2H5NH, C2H5. So 1 is the primary amine, 2 is the secondary amine. And NN-dimethyl, NN-dimethyl ethylamine. So this is tertiary amine. We need to comment on the increasing order of boiling point. When I talk about the boiling point, over here primary amine shows the highest number of hydrogen bonding. Then the less is with the secondary, and tertiary will not show any kind of hydrogen bonding. So this will be having the lowest boiling amongst the three. Second lowest is this second one, and the highest boiling point is with the first one. Therefore option A. Question number 86, an organic amino compounds, it's reacting with the aqueous nitrous acid at the lower temperature to give the oily nitrosamine. Oily nitrosamine is formed by the secondary amine, and out of this the secondary amine is option C. Hexose and pentoses, disaccharides, monosaccharide, polysaccharide, oligosaccharides. They are monosaccharides. Buna-N. Buna-N is a polymer of butadiene with acrylonitrile. Therefore, option B. The intermediate which is never formed during the chain growth polymerization. Generally, chain growth polymerization gives us the formation of free radical like A and D. Also gives the formation of the carbocation, but they will never give the formation of carbene. Hence, option C. Aspirin. Aspirin is generally given as OCOCH3 COOH. So this is acetyl derivative of salicylic acid. So acetyl salicylic acid.